So, okay, we should start now. Our topic is market basket analysis. As from the word, you can see that we are analyzing the market basket we use during shopping in the retailer stores, e-commerce, or in any grocery store. We are analyzing that what type of products the customers are usually placing in their basket. So here you can see there are some libraries that pandas, NumPy, Seaborn, Matplot. Pandas is for data, NumPy for numerical analysis, Seaborn for more complex graphs, Matplot and up to so on, MLX10 pre-processing for transaction encoding and frequent patterns to use a PDO algorithm and also to detect the association rules. Basically, we are using here the PDO algorithm to detect the frequent buying items. Now the parallel coordinates. First of all, if we run this, it's okay, no error. First of all, you have to do is to mount your Google Drive from here. Either you can mount from here. I have mounted already, so that's why it's giving the unmount drive option. Or you can do from this part of code and you can run it. It will ask you to connect to Google Drive. Now you can see then you have to give it that you have to continue from your email, etc. Then it will be mounted. I am not doing this because I have already done with this button. Now we have created a data frame in which we have p.read CSV. We are asking to read our CSV file, that is market basket analysis, where it is put in the data analyst folder in my drive, in drive from where content. You can see whole path here. You can copy the path from your drive like this. You can scroll here, my drive. It's like content, drive, my drive. Now in my drive, you will see data analyst folder. In this one. And up to so on, you can copy wherever your project is placed like this. If this is the project, you can copy the path from here and put in this code. Now, what I have done is that print my data frame, that what type of data I have. Here you can see the columns that represents the items that are present in the data set. You can say that items present in the grocery store, apple, bread, butter, cheese, corn, up to so on. And here the rows represents the entries. These are the entries. You can say that these are the baskets. There are total 999 rows, mean 999 baskets data. I can give you understanding of the first basket, that there is a basket named 0, suppose, and there isn't any apple there. That basket consists of bread, corn, dill, ice cream, and up to so on, sugar, and up to so on. Okay, so you can say that up to so on from this 0 to 999 baskets. Now what we are doing is that we are dropping the data frame column 0 axis 1. Why we are dropping column 0? Because this column 0 is only indicating the column number or the row. This is only indicating basket number or the row. So it is like you can say that it's a serial number. So we don't need it in our further analysis. So we can drop this column. And axis 1 means that there are two type of axis 0 and 1. 0 is used for rows. If you want to drop a row, you can use axis 0. But if you want to drop a column, you have to use axis 1. In place, we have set in place true. In place means that we are going to update our existing data frame. We are not going to create a new data frame. Now we are printing our data frame, and you can see there isn't any serial number. This is the Google Colab serial number that is not present in our data set. As you can see, there were two columns. Now there is only one, that is of Google Colab. Your data set now doesn't consist of a column with serial numbers. Now we are getting the data frame. I have run these um, cells already, so not running it here. We have 999 baskets for us, as I have told you, to compute the recommendation for each item that's sold in the store, and there are total 6 items that sold in the shop. These codes are basically giving error because there was mounting issue, but I have run them already, as I did mounting again for you, so that's why it's creating an issue. Now we are calculating the mean of the all over the items that are present. Mean of apple, you can see, of cheese, eggs, up to so on, they're all in the range of 0.3 to 0.4, and we are basically saying that all data types are in form of float, so there isn't any data type issue. The sale transaction or count for each item, unique item approximately for this sample, we will dive into and see whether there is any difference or correlation between the baskets. Since the data frame is already tabulated one hot data frame, and we will straight away use the data set to be then analyzed with a priori algorithm. Now, in this, you have to see basically the correlation, the association relationship between the frequently bought items. So now we are computing the frequent item sets using our algorithm. In our algorithm, we are using the data frame minimum support. Minimum support is basically minimum threshold that we have set to 0.006, that this much frequency should have that item if we are considering it. Maximum length, you can take one item, two item together, or and maximum up to 3 items. Not you can give us a relationship between 4 items. We need just maximum 3 items relationship. And you can use column names. We have given this true so that it is easy for us to analyze using the names. Now we can see here we have run this frequent item sets variable as a period was applied to it. It has given some serial numbers, and support is basically the frequency of how much that item is bought. Now we can see the item sets apple, bread, butter, cheese, and this is a maximum of 3 length, 2 up to so on. We can convert this into tabular format as well. And also we can convert it into suggested graphs, charts. In this one, time series and 2D distribution and distributions. Okay. Now we are computing the association rules for frequent item sets. What type of association rules are we applying to it? We are giving our frequent item sets variable and matrix support and minimum threshold is 0.1. What type of matrix are we going to analyze? The frequency, how much frequent that item is present. Now, after applying the rules, we are analyzing our rules. Now you can see here we have serial items, serial numbers. Now here are antecedents, consequents, antecedent support, consequent support, up to so on. Antecedents is like if you know the mathematic relation, that is, or statistical formulas, if and then relation. Antecedent is used as if and consequent is used as then. Here you can say that if apples are bought, then bread is also bought. Antecedent support is basically how much this antecedent is brought frequently and how much consequent is brought frequently, this consequent support, and this support is overall how much they are both brought together. And confidence says that how much this rule is true. Lift suggests that how much there is frequency percentage of the products that are bought independently. And leverage leverage is same as like this. And conviction, you can say that you can see their mathematical formulas. Conviction is like same as lift, but lift was how they are brought together and conviction is how they are bought independently. And Zhang's matrix is basically a type of matrix that we are going to use for analyzing our association rules. These terms are interrelated to each other. You can see their mathematical formulas, and there isn't any need to get into detail to these formulas or terms. Now we are applying the filtered rules, like we are giving our antecedent support must be greater than this, or consequent support must be greater than this, confidence and lift. We are giving some random values. Now we have applied filtered formula. I should run this. Now, what type of filtered rules have we applied and what is their result? That is consequent antecedent support should be greater than 0.02. It is 0.02. Yes, it is greater than 0.02. Now filter rules dot sort values. Now we are sorting our filtered rule values uh, mm, on the basis of confidence, and ascending is set to false means that we are uh, sorting it in the form of descending order. You can see the confidence, it is sorted in the form of descending order from greater to small. Now we are generating a scatter plot for support and confidence to see that where should we set our thresholds. As here we have used just random values, now this will give us the exact range. I should run this, or as it is already done, but for you guys, you can see the consistency at this point, at this, and at this, between confidence and support. Now with the scatter plot, we have a quick glimpse where the boundary should be and what matrix should be set to filter out the frequent item sets. Now we are filtering out more. Filtered rules, we are giving these values according to this graph, you can see. And now applying this, and after this running the filtered rules, and we are getting the results based on above filters. Now generating scatter plot, confidence versus support, setting some leverage and data sets up to so on, giving more precise values. Now we have applied lift parameter and support parameter also. Now here we are going to run now the filtered web rules. You can see the values. You can we can take only one, like the support must be greater than 0.1. Yes, it is true. Now we are creating a function where we are going to create new columns for antecedent consequence by applying this lambda function. We will be applying our rules. Now we will adjusting the rules previous rule index to new rules and returning that antecedent consequent and rules. Running it. You can do all this data analysis according to your way, but I have chosen this way. Now converting rules into coordinates suitable for use in a parallel coordinates plot. Uh, we have applied this rule, this lambda rule, or creating the new columns for this because we are going to use this parallel coordinates plot system. Running this. If you are using another plot or graph, you can use some other rules here. Now you can see uh, that cross relationship between the antecedent and the consequence. You can see the maximum lines at butter point. So what you can do is that butter could be brought with any product. It is frequently bought, and the products that are less frequently bought, you can set them with butter, apply less rate or discount to the butter so that less frequent items should be bought with butter, and you can apply some deals for the products that are not much sold and apply that deal with butter product so they are also bought frequently. From this plot, it seems like the butter can be used as a cross-selling with other products. It also acts as something to be offered with antecedents that is low. Thus, the customers are more likely to buy them if the buttered are offered with cheaper price, if they buy the antecedents that sold less in a store. Thank you. So it was all. You can subscribe, like, comment, share whatever you want, and you can suggest some other topics as well if you want more videos. Press the notification button to get updates on new videos. Thank you.